Hello everyone, welcome to my channel Content Hub. In this class I am going to explain one type of the collision resolution technique, that is closed hashing. In previous class I have already explained about the open hashing. So in open hashing we were using the linked list, and why we were saying that open, because the element whenever the collision occur it stores the outside the hash function. That's the reason I'm saying that's the reason we were saying that open hashing. In closed hashing everything is inside the hash table, so that's the everything is inside the hash table. It's called, because of that reason it's called closed hashing. So closed hashing is also called open addressing. Closed hashing is also called open addressing. So here what is saying that closed addressing stores all entry record within the array itself. Same thing I have said that. Now we'll see the all these types of the closed hashing. We'll see the all these types of the closed hashing, but here I just explained about the linear probing and their everything about the linear probing. And this is very much important, not for the engineer student, it's also important for the other student, those who are going for the GATE exam as well as NIC and going for the NET exam and any competitive exam. Going for the technical part, all these exam is asking question from the linear probing only, because this is the basic concept only, and there are so many small thing is there in the linear probing, and that's very much important. So I'm going to cover all these thing in this video, so please watch till end, because it's very much important, not for this your course subject, as well as in the future also if you are going for the any competitive exam, it is going to help you out, and also it's help you in the interview. So I have taken here one, so what is the linear probing? The name is saying that linearly, and probing it means that search. Probing means search. Linear means linearly, means one by one. You have to, so how you search the element? You have to search the element one by one, right? So now we'll see that, and don't confuse with the linear search and linear probing. So if you, I'm saying here one by one you have to search, so you can why we say that the time complexity is constant time. So guys, this is linear probing and that's linear search. So difference is that in linear probing is that it's a hashing, means here it's working key value pair. It's working with the key value pair, means here there is a concept of the index, and because of that reason it's getting constant time. And in linear search there is no concept of the key value pair. There you have only keys and directly you are matching with that key. So because of that reason, that's take time complexity order of 1, and here it's taking order of constant time, right? So here I have taken example. I'll first explain you that why linear probing, how linearly checking that. So that I'm going to first explain, then we'll explain about this formula, why I have written these things. I'll explain these things after this example. So I have taken one example that my table size is 10 and I'm using the collision resolution technique, is that linear probing, and hash function is given that k mod 10 and key value, some key values is given. So I'm going to calculate index using the normal method. Using the normal division method, I'm going to calculate all this key value index. So 70 I'm going to calculate index using this hash function. I'll get the index value 0. So first, in starting my table was complete empty. This was not stored. You assume that this was not stored. I have already written, because of that PPT I have prepared. So you assume that your table is empty. Nothing was there in this hash table. Nothing was there. So this 70 is going to store at 0th index. Next is 93. So if you are going to calculate the index of the 93, you will get the index 3rd. So this 93 is going to store at the 3rd index. Next is 82. If you are going to calculate 82 index using this hash function, you will get the 2nd index. So 82 is going to store at 2nd index. Next key is 41. If you are going to calculate index of the 41, if you will get the index is 1. So 41 is going to store at 1st index, and 70 is already stored at the 0th index. So now you can see the table 0th, 1, 2, 3 is filled. Remaining part is empty. Now 4, 5, 6, 7, 8, 9 is empty. Now the next element is came 50. Now his next element is 50. So if we calculate the index of the 50 using division method, then 50 modulus 10 you will get the index value 0. So now look at your table. 0th index is already filled by 70. So what this situation is called? This situation is called collision. So you cannot store 50 at 0th index. Now the linearly how we are going to store this 50 linearly, that I am going to explain. I'll explain the meaning of the linear here in this linear probing. So what will you do? How do you store this 50? If collision occur, in general definition I am saying that, so if 50 index got index value is 0, so first go to the 0th index, check that is 0 free. No, it's not free, it's not free. Then check the immediate next index. Linearly you check immediate next index, is it free? No, this is also not free. Then check next immediate index, is it free? No, this is also not free. Then check another next immediate next index, is it free? No, it's not free. So next again you check that immediate next index, is it free? Yes, this is free. So 50 is going to store at 4th index. 50 is going to store at 4th index. Now 60 came. Now 60 came. Then 60 is in the index is also coming 0, but you have seen that 0 is already filled with 70. So you will not going to store 60 at 0th index. Then what will you do? Using the linear probing and the general formula, without going for the formula, I am just explaining that how will you going to store the 60. So 60 is not going to store at 0th index because it's filled. Now what will you do? Check immediate next index, that is first. Is it free? No, it's not free. Then what will you do? You check the immediate next. Is it free? No, it's not free. Then another check immediate next. Is it free? No, it's not free. Again you check that. Is it free? No, it's not free. Next immediate index. Is it free? Yes, it's free. So this 60 is going to store at 0th index. So what you have observed here? Unnecessary search you are doing. That's the disadvantage that I'll explain after this example. I'll explain in sometimes. So see here, 60 is stored at 5th index, right? This is nothing but this process. You are checking that immediate next index, immediate next index, immediate next index. This is nothing but a number of search or number of probe, you can say that. So here name is saying that probing. So this search is nothing but a number of probe, and this is also one very much important question mostly asked in the competitive exam. So they will just give you this key element and they will ask you the number of probe for the 60. What are the number of search for the 60? They can ask you. Similar like that, they can also ask you the number of probe for the 50. Number of probe for the 93. This type of question come in the interview also and in competitive exam also. Now coming to the formula. What I have written, if no collision occur, then you simply apply division method. If there is a no collision occur, simply apply division method or any other method to calculate the index. And same thing I did it here, same thing I did it here, same thing I did it here. I haven't applied any linear probing because so far I haven't got any collision, so I haven't applied. When I applied linear probing, this for 50 and 60 because here collision occur. Here collision occur, that's why I applied linear probing, and for that what I did, I checked that immediate next, and that is going to done by what? H of x plus 1 plus I, and I value is 0 to m minus 1, and you are checking what? Immediate next means what? You are incrementing by 1. Then again you are doing what? Immediate one. So immediate next, that's also increment by 1. So that's nothing but a h of x plus I modulus m. So same concept I have given in the general method. If you are going to convert this general method in the formula, that's nothing but a h of x plus I modulus m. Okay, so now I have taken another example for linear probing only, and in that I have given the proper question for that. Given array, and this array is having this many element, and it's also saying that apply division method. They have mentioned that which method you apply for the calculating the index, right? And also saying that open addressing. Open addressing, it means that closed hashing, right? And closed hashing type is linear probing, quadratic probing, and double hashing. But here they are not mentioned that which types of the closed hashing will you apply. So by default, if it is nothing given, if nothing, no type of closed hashing given, then do apply linear probing. So here not mentioned, so by default I am applying linear probing technique. And they have also given hash function is h of k equal to 2k plus 3 and m equal to 10. M is nothing but a table size. So now I have calculated index of the key value. I have prepared the table here, so it will easy to understand here. So I have calculated for the index for the third element, and using this hash function 2k plus 3, I got index is 9. I got index is 9. Here I'll go and check the table. Is my 9th? See, this is my first key. It means that my table is empty. So now I got the third key's index value is 9. So I'll go to the 9th index. I'll store third at 9th index. So here there is no collision. So I'm not performing any linear probing here. I simply use division method. I calculated. Now the second element is 2. Now second element 2 came. So if I calculate index of the 2, I'll got the index value is 7. So this is the second element. So I'll go to the 7th index. This is free, so 2 is going to store at the 7th index. Now next element is 9. If I calculate using hash function index, we got the 3. Here also no collision. This is the third element, right? And if I go to the index first, there is nothing there. It's empty. So 9 is going to store at 1 index. Next element is 6. If I calculate the index, that I'll get the 5. I'll go to the 5 index. It's free, so 6 is going to store at 5. So far I haven't applied any linear probing. It's just in normal division method. Now the next element came the 11. So far I haven't applied any linear probing, and because of that reason the number of probe of each and every element is what? 1. So if no collision occur of an element while calculating the index, the number of probe equal to 1. Okay. Now 11 came. So if I calculate the index of the 11, I got the index 5, and if you go and check your table, is 5th index is free? No, it's not free. Then what will you do? Now apply linear probing. Here you apply linear probing, and for that reason I have calculated this. For that reason I have calculated this. Using formula I have calculated. General method, you simply check that immediate index, is it free? See that what index you are getting? 5th index you are getting. So 5th index is not free. Then what will you do in general linear probing? Immediate next, is it free? Yes, free. Then you can store here. But no, I am not going to explain here general method. I am going to use here formula. So using formula, what will you do? I said that h of x plus I modulus table size, and I value is what? 0 to table minus 1. So here table size is 10. So I value is going to 0 to n. So 0 to 9. So if, I have got that index for h of x value is what? 5. H of x value is 5. So 5 plus 0 modulus 10, I'll get that 5, and that is not free. Then what will I do? 5 plus 1. I value now incremented by 1. So 5 plus 1 modulus 10, will get that 6. Right? So we'll go to the 6th index. Is it free? Yes, free. Then 11 is going to store at 6th index. So 11 is going to store at 6th index. Okay. Now what will you do? 13 will come. Now 13 will come. So for 13, what will you do? Calculate the index. You got the 9th. Go and check that 9th is free. No, it's not free. Right? Then what will you do? Then apply linear probing. Calculate index. H of x value is 9. 9 plus 0 modulus table size. Again you got 9. That's not free. Then increment I value. 9 plus 1 modulus 10. You got 0 value. So now go to and check that 0th is free. Yes, 0th is free. Then 13 is going to store at 0th index. So I'm writing here 13 is store at 0th index. Okay. So first time you check that 0th index, sorry, ninth index, it was not free, first probe. Second time you got that 0th index and that is free, so 13 is stored. So in 2 time you got that place, there you stored 13. So number of probe for 13 is 2. 7, for the 7, if you got the index, calculate the index using division method, you will get the 7, and that if you check the hash table size, at 7th index already 2 is stored. Already 2 is stored. So what will you do? Apply linear probing, go and check that. So if you do with this, first 7 plus 0 modulus table size, you got that 7, that's not free, this is called first probe. Second time what will you do? Increment I value equal to 1, 7 plus 1 modulus 10, you get that 8. Go and check that is 8th index is free. Yes, it's free. So second time you are getting that free place. So the number of probe for the 7 is also 10. Sorry, 2. Number of probe for 7 is also 2, and this 7 is going to store at where? At 8th index. 7 is going to store at 8th index. Now 12 came. Now 12 came. If you calculate the index, you are getting what index? 7. Go and check the table. Is 7th index is free? No, 2 is already stored there. 2 is already stored there. So you cannot store 12 at 7 index. Then what will you do? Then apply linear probing. Then what will you do here? H of x value is 7. 7 plus 0. 10 modulus 7, this is not free, this is called first probe. 7 plus 1 modulus 10 equal to 8, go check that it is free, no, not free. Then this is second probe. 7 plus 2 modulus 10 equal to 9, no, this is also not free, this is third probe. 7 plus 3 modulus 10 equal to 0, go to check that 0, no, not free, this is fourth probe. Now 7 plus 4 modulus 10, you are getting 1. Is this free? No, this is also not free. This is fifth probe. Now 7 plus 5 modulus 10 equal to 2. Go check that 2 is free. Yes, this is free. This is the sixth probe. So number of probe is 6 and this is free. So 12 is going to store where? 12 is going to store at second index. So 12 is going to store at second index. Now we'll see that the order of the element in the hash table. We'll see the order of the element in the hash table. So what will I write here? How calculate? Because this part is very much important. This ordering is very much important for the competitive program. They directly ask you the order of the element, right? So order of the element in the hash table they'll ask you. So this order is what? 0th index what value? 13. 1 index what value? 9. 2 index what value? 12. 3 index is free, so just give that some symbol like a dash or underscore, so will show that it's an empty place. Now 4th is also free, so just denote with dash, so you can they can understand this is a free place. Now 5th index is 6, 6th index is 11, and 7th index is 2, 8th index is 7, and 9th index is 3. So like that you can write it in a write the order of the element in the hash table. Okay. Next we'll see the advantage and disadvantage of the linear probing. So advantage of the linear probing is that no extra space. Advantage of the linear probing is no extra space, because what it is doing that linearly it's checking that wherever the space is free they are storing it, right? So this is the advantage of the linear probing, it's using all this space. Disadvantage is that the searching time of in worst case is that order of n. The searching time of the worst case of the linear probing is that order of n. Next one is saying that deletion is difficult in the linear probing. Yes, why so? Because look at this table. Look at this table. This is making that one cluster. This is called one type of cluster. Cluster means what? Group you can say that. So this table is divided into two parts, means there is a two cluster is forming. This is one cluster and this is another cluster. Okay. Now we say that if I say that, suppose if I am saying that delete the element 2. Suppose I am saying that delete the element 2 and you start checking from the, suppose here I am not following any formula. Then what will I do? Here I following any formula. So if I'm going to delete the 2 and suppose I'm start from this index, 6th index, and I'm deleting the 2, what will I do? I start checking from the 6. I'll start checking from the 6 and I'll check that is my 2 is available at 5th index. No, it's not available. Is 2 is available 6th index? No, it's not available. It's 2 is available at the 7th index? Yes, it's available. You can say that it's present. Okay, this is the easy method. This is the easy method. You can simply delete the 12. So suppose now I have deleted. Suppose I have deleted the 12. Suppose I have deleted 12. So now this is the free space, right? Now what will I do? Suppose if I'm going to delete 7. Suppose if I'm going to delete 7, then what happened? I'll suppose I'm going to start from the 5th index. So 7 is matching with 5th? No, it's not matching. Then 11, not matching. Then came here. Now came here. It was empty place. So what it will tell you that? It will tell you that this is the empty one. It means that it's stop here and it will directly give you the message that there is no element 7 in my hash table. And that was the problem with the linear probing. So what's the thing it's saying that? So whenever you are going to perform deletion in the linear probing, what will you do? You will replace the element with some marker value, so it can help you to check the another slot, is the element is available or not. So this is the deletion is that's the reason deletion is difficult. Next is that primary clustering is the also disadvantage, and second is secondary clustering, that I'll explain in the next video. Thank you for watching my video. This is all about linear probing.